Welcome back to the Pre-Calculus Mastery Program. So far, we have learned how functions take an input and transform it into an output. We also learned how to reverse functions using inverse. But now, let me ask you something interesting. What if we combine two functions together? What if the output of one function become the input of another one? This is called a composite function. Today, we will learn how functions can work together step by step and how this creates powerful mathematical relationships. A composite function means applying one function and then applying another function to the result. Think of it like a two-step machine. First machine processes the input, then the second machine takes that result and processes it again. We write composite function like this: f of g of x. This is written as f of g of x. This means first apply g of x, then apply f to the result. Let's take an example. F of x is equal to x plus 2 and g of x is equal to x square. Now find f of g of x. For that, step 1, apply g of x. G of x is x square. Then step 2, substitute g of x in f of x. So f of g of x is equal to f of x square. Now apply f. Actual f of x is x plus 2. So we are substituting g of x into the f of x. So x square plus 2. So the final answer is f of g of x is equal to x square plus 2. Now let's try the opposite. Find g of f of x. Step 1, f of x is equal to x plus 2. Step 2, apply f of x in g of x. So g of x is x square. So in the x, we replace x plus 2. So g of f of x is equal to x plus 2 the whole square. So we get a different result. See, this shows something very important. Composite functions depend on the order. F of g of x is not the same as g of f of x. Let's understand this with a real life example. Imagine, first you cook food, then you serve it. This is one order. But if you try to serve first and cook later, it does not work. Order matters. In the same way, composite function depends on the sequence of operations. Think of composite functions as multi-stage processing. Each function transforms the input step by step. This is very important in computer programming, engineering systems, and mathematical modeling. Today we have learned about composite functions. A composite function applies one function and then applies another. Also we have learned f of g of x means applying g first, then f. Then g of f of x gives a different result. Order matters in composition. These ideas help us to understand complex transformations. Please try to solve this problem by yourself and also explain why the results are different. When you understand composite functions, you begin to see how mathematical operations can be laid step by step. And this layered thinking is essential for advanced algebra and calculus. Thank you for learning with me today. Keep practicing, and I will see you in the next lesson.